episode of the Office Hours. In this episode, we're going to be doing another network lesson on BGP communities. So a BGP community is a bit of extra information that you can add to one or more prefixes which is advertised to BGP neighbors. This extra information can be used for things like traffic engineering or dynamic routing policies. There are 4 well-known BGP communities that you can use, or you can pick a numeric value that you can use for your own policies. Here are the 4 well-known sorry guys. Here are the 4 well-known BGP communities. The first one being Internet, and for Internet, it says it'll advertise the prefix to all BGP neighbors. For no advertise community, we don't advertise a prefix to any BGP neighbor. And for no export, we don't advertise the prefix to any eBGP neighbors. And for local AS, we don't advertise the prefix outside of the sub AS. This one is used for BGP confederations. Once you finish reading this lesson, click on one of the links above to learn more about the well-known BGP communities. I explain them each in separate lessons. So why do we call them communities? Communities is a group of prefixes that should be treated the same way. For example, maybe you have 100 prefixes that require the same local preference or weight. You can match all prefixes using an access list or a prefix list, but using BGP communities is more convenient. Instead of manually selecting the prefixes, an ISP could instruct the customer to tag prefixes with a certain BGP community. When the customer does this, their prefixes get a certain treatment. To give you an idea, here are some examples that I found from level 3. Let's see. Customer traffic engineering communities, pre-pending. I'm guessing they're using AS path prepend, and this tells it to prepend twice, 3 and 4 times. What is this? This is regional. Only work with regional peers. Looks like more prepending. And this one looks like it's going to use local preference. This list might not be up to date anymore, but it gives you an impression of how BGP communities are used. If a customer of level 3 tags their prefixes with 3356:90, then they will set the local preference to 90. So that's this line right here. And if you tag them with 6498.3:0, then they will prepend the AS number 3 times to all their BGP neighbors in Europe. Let's see where that is. 6498.3. So right here. These BGP communities are 32-bit values that are divided into sections. For labs, you can pick whatever value you like, but normally the first 16 bits are used to indicate the AS number that originates the community. The next 16 bits are assigned by the AS. For example, level 3 uses these communities. Okay. The first 60 bits is their AS number, which is 3356, and the next 16 bits is either 70, 80, or 90, corresponds with the local preference value. On the routers, they configure a policy that sets the local preference to these values if they receive prefixes with these BGP communities. Nowadays we use extended communities, which are 8 octets. These are used often for MPLS VPN, which we will discuss in another lesson. Let's take a look at configuration examples so you can see how to implement BGP communities. For example, I will use the following topology. Looks like, does he show any configurations? Let's see. Yeah, actually he does. I should probably copy this over. All right. To snip. save that as 21. Over here, start a new file or a new project, and copy. Oops. Oh man, I have to edit all that out now. Crap. All right. Let's see. All right. Let's do a view. Snap to grid, show grid, and I'll paste this image in here. We'll give it ISP2 as a name. This one ISP1. And this one will be ISP3. And R1 will be customer. Okay, all right, let's connect these. F10. Over here we have F00 to F00. Down here we have Down here we have F01 to F00. We'll try to snap this. Snap this. All right, cool. Yeah, all right, let's turn up these nodes. And we'll open up a terminal for each of them. All right, so we're over at the customer router. First thing I'm going to do is I'm going to configure that loopback interface. IP address 10.10.10.10 with a mask of 32. And we have the fast Ethernet 0/0 interface to configure. So I'm going to give it that an IP address of 192.168.10.10. Yeah. Oops. With a /24 subnet mask. We'll also configure the router or the BGP with an autonomous system number of 10. And what else? I think he's going to have a neighborhood or a neighbor statement to ISP1 router with its IP address of 192.168.10.1. Oops, with a remote AS of 1. And I think he's probably going to want to advertise that that /32 out. So I am thinking that they're going to use the network statement. So let me do that. And if not, I'll change it afterwards with mask 255.255.255.255. And I think we should be done here. All right, so let's go to ISP1. We will configure all three physical interfaces. FA10 connecting to the customer router. Give it that an IP address of 192.168.10.1/24. Do FA00. Give that an IP address of 192.168.12.1. Another /24, and I actually forget to no shut the first interface. So I'm going to do that right now before I forget. No shut, and we're going to go to the last interface, FA0/1. Give that an IP address of 192.168.13.1. Give that a /24 subnet mask. No shut this. And we have 3 BGP neighbors to configure. So router BGP 1, then do the first neighbor as the AS10. So 192.168.10.10, and remote autonomous system will be 10. Then the other neighbor is going to AS2 with ISP2 with their IP address of 192.168.12.2. Remote AS2. And lastly, our neighbor down at ISP3 will have an IP address of 192.168.13.3 with a remote autonomous system number 3. I think that might be it for now, until we have to apply some communities, possibly. So we'll do an N, we'll do a write mem, and we'll move over to ISP2. Alright, so for ISP2, we only have one physical interface to configure, FA00, IP address 192.168.12.2 /24, no shut, and we're going to configure BGP. We're going to configure it with autonomous system number 2, and we're only going to have one neighbor to configure, and that's with ISP1. So the IP address we want to use here is 192.168.12.1. 0. Oops, no mass. I am getting tired, maybe. So it's going to be autonomous system 1 there, and that's it for now. Do write mem, move over to our last router to configure. So again, we only have one interface to configure. That's FA00. Give that an IP address of 192.168.13.3 with a subnet mask of a /24. No shut that. We'll configure ISP with BGP autonomous system number 3, and we'll configure it with a neighbor statement connecting to ISP1 with an IP address of 192.168.13.1 with remote AS number 1. I think that's it. Alright, so moving to the ISP1 router, let's see if I typed in everything correctly, because all 3 other routers should be appearing under the show BGP show IP BGP summary output. Yep, they all appeared except ISP, or actually it's not appearing over at the customer router. It looks like it's stuck in active state. So what does this mean? This probably means that one of the interfaces might be still down, possibly. Show IP and brief. So it's up there. Let's go to customer, show IP, or show IP interfaces brief, right? So yeah, it looks like over at this router, we can see, as I will highlight here, FA00 is currently administratively down. So I forgot to put the no shut statement at fast Ethernet 0. So I'll fix that right now by going to interface FA00, doing a no shut, and write mem. And in a moment, we're going to go back to ISP1, and we're going to see better progress than before. It usually stays in active state for a while, longer than most other states. Okay, so it's in open sent, and now it's up. And it received a single prefix from the customer router, and that prefix should be the /32. So we can verify that by doing a show IP BGP, I think. Yep, there it is. All right, cool. Let's move on here. On the left side, we have a customer router that is connected to ISP1. This ISP is connected to ISP2 and ISP3. Let's imagine that ISP2 is somewhere in Europe and that ISP1 has a policy that they will prepend their AS number 4 times to BGP neighbors in Europe whenever a customer adds BGP community value 64984:0 to their prefixes. Let's see how we can configure this on ISP1 and the customer router. So we're at the customer router. We have exactly what I've already inputted in our lab configuration. So we'll move over to the ISP2 router. And nothing different here. It looks like all he has is 3 neighbor statements here, so it should be good. And same with ISP2, it's just a neighbor statement, and ISP3. So he hasn't put in any configurations that will affect communities so far. Alright, so over at ISP1, he's checking if it's learned any prefixes, and it looks like it has. He's doing show IP BGP with a specific string of 10.10.10.10, and it is showing up with results. So it's saying that it's learning it from the customer router at 192.168.10.10. So ISP1 has learned the network on the loopback interface of the customer router. Right now, we don't have any BGP communities. Let's start with configuration of ISP1. Alright, so ISP1 AS path prepend configuration. So let's go to our ISP1 router and we'll enter configuration mode. And we'll do IP community list 1 and we'll permit 6498.4:0. Author says this community list is similar to an access list or a prefix list, but only used for BGP communities. Next step is to create a route map that will prepend the AS path whenever we see this value. Alright, so we're still at ISP1. We're going to create a route map. And we're going to call it prepend_EU. And we're going to permit it with a sequence number of 10. We're going to match community 1. And we're going to set AS prepend 4 times. And we'll exit out of here. So we finished our route map. And what else are we doing? We're also doing route map prepend EU. Then we'll insert a sequence of 20 and we'll permit it. This route map matches on community list 1 and prepends the AS path 4 times. Let's attach it outbound to ISP2. Alright, so going to our router or our BGP configurations. We'll have neighbor 192.168.12.2, which is the customer. No, not the customer. This is to ISP2. And we'll apply a route map of prepend EU, and we'll set it so that it affects outbound traffic. Oops, did out twice. Alright, and this takes care of the configurations of ISP1. Let's configure our customer router to send the BGP community with its prefix advertise, or with its prefix advertisement now. Alright, so we're moving over to the customer router, and we're going to be creating a prefix list. And we're going to call it loopback. I'm going to give it a permit statement, and this is going to be the address of its loopback address, which is 10.10.10/32. And we'll create a route map. We'll set the community here, or we'll give it a name of set community. We'll do a sequence number of 10 with a permit statement. We're going to match IP addresses in the prefix list that we just created. We'll set this community as what we configured back at the ISP1 router 64984:0. Exit, and we'll give it one more statement with a sequence number of 20. Route map set community. Alright, and then we'll go to router BGP, or we'll go to the BGP configurations, and for its only neighbor, which is ISP1 with IP address 192.168.10.1, we're going to apply a route map. Route map. And with the name set community, we're going to apply outbound. And okay, here's a new command. For neighbor 192.168.10.1, we'll use the statement send community. I mean, what does it even mean? Send community attribute to this neighbor. So I guess without this, none of it is going to work. I wonder if we can verify that somehow. Can I just go to ISP1 and see how it is now? Let's do a show IP route, or show IP BGP. Is that what I want to see? It's not really showing much here. What if I do a clear IP BGP star? Is it gonna show me anything new? Oh, it's not showing me anything now. That is kind of scary, actually. Show IP BGP summary. What's going on here? It's receiving no prefixes now. In that case, let's input this send community string in there, and I'll do an enter there, and we'll go back to ISP1. Okay, so it looks like that statement is required for the prefix to even be sent. That's interesting. I learned something new. Take a close look at the second command. We have to use the neighbor send community command because the router doesn't automatically send BGP communities to its neighbor. Everything is in place. Let's verify our work. All right, so where's verification method? Customer, or the author goes to the customer router and does a clear IP BGP asterisk, or he clears the BGP cache. So let me do that and see what happens. And while that's happening, we'll refresh this. Looks like it went into established state real quick, although it isn't seeing any prefixes yet. Why is that? Is it because I have to clear the BGP cache over at the ISP1 side as well, or does it just take time? I mean, show IP BGP. Nothing is coming up. Let's see what the author does. So for ISP1, looks like he does a show IP BGP 10.10.10. Is it show? Oh, okay. So it finally updated with one prefix. So I'll do that. Show IP BGP .10.10.10, and yeah, we're going to see the community that we inserted. This looks interesting. It did receive our community value, but it's showing up as a 32-bit decimal number. There's a command on Cisco iOS that lets you choose between this output and the output with 16-bit values. So let's change it to the 16-bit value. Okay, one IPBGP community, new format, and looks like it's looking a lot more familiar with the colon. So this is what we configured on the customer router. Show run section BGP. Is that where we'll be able to see it? No, it's not. It's going to be over at the route map. Alright, so we have the prefix list here that matches its loopback address, and we have a set community command right here, and it actually changed it to the 32-bit value. Interesting. Cool. Alright, let's go over to ISP1, or ISP2 actually, sorry. And do a show IPBGP, and it's not seeing anything. So why is that? Show IPBGP summary. Is it having any issues connecting with ISP1? Nope. But it's not receiving any prefixes. Why is that? Show IP route. Clear IPBGP. Is that what we need to do? And if we have to do it there, do we have to do it here? Clear BGP, or clear IPBGP. Got a star. Oops, I accidentally did twice. What I really wanted was to see something in this table, but nothing is showing up. Show IPBGP. Alright, so ISP3 is showing the results that we do want. It's showing the loopback address of the customer router, which was propagated from the customer to ISP1 and out to AS3 on the ISP3 router. So if we do show IPBGP and thus address, what's it gonna say? It's not gonna say too much. Didn't we configure ISP1 to do something? Alright. So for its neighbor, 192.168.12.2, which is ISP2, we're gonna prepend 1 4 times, or itself 4 times, and that's going outbound. However, I don't think we applied this route map to ISP3. So let's check ISP2 again. Show IPBGP. Still not showing anything. Show, maybe I misconfigured it. So going back to ISP1. Show run. Let's see where our problem is. Alright, match community 1. Now, we're going to apply this route map out, and I realized what the mistake is just now. The route map I did not type correctly. It's supposed to be prepend with a D, and apparently I'm missing that D. So let's fix this. Not in BGP or router BGP1. We will do a no on this statement. And then we will type it again correctly. Route map prepend underscore EU out. And do an right mem. Go back to ISP2 and hopefully something has changed. If not, I'm gonna just clear the cache. And there it is. So, looks like there's a prepend of additional 4 artificial hops as we configured in ISP1. So it looks like everything's working correctly now, while ISP3 did not have AS path prepended to its prefixes that were passed from ISP1, so it should be fine. Show IP BGP. So over at ISP3, we're only going to see the AS number 1, as it's not prepending here. That might be it. Just as expected, ISP1 router has prepended the AS path when it advertised the prefix to ISP2. Next time our customer wants something prepended, they only have to send the correct community value. I hope this example has been useful to understand BGP communities and what BGP communities are about and how to implement them. Of course, we can still have our well-known communities. All right. I think that's it. Stream for this lesson took about 30 minutes. Nice. This is probably one of my longer lessons. All right. Thank you for watching, and I will start up another session on BGP community no advertise.